Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 9th graders 2022, problem number 2. This problem has two connected parts. Part A, we wish to prove that 2x cubed minus 3x squared plus 1 is greater than or equal 0 for all x's greater than or equal 0. And part B, that x, y, and z be non-negative numbers satisfying the following condition: 2 over 1 plus x cubed plus 2 over 1 plus y cubed plus 2 over 1 plus z cubed equals 3. We wish to prove that 1 minus x over 1 minus x plus x squared plus 1 minus y over 1 minus y plus y squared plus 1 minus z over 1 minus z plus z squared, this entire sum is greater than or equal 0. So here are my hints. Part A is very straightforward. Just do factorization of this polynomial by writing it in the following way: 2x cubed minus 2x squared minus x squared minus 1. And then use part A, because part B would be quite challenging without part A, but given part A, it is probably a hint for part B. So show the following: that 3 times 1 minus x over 1 minus x plus x squared is greater than or equal 2 times 2 over 1 plus x cubed minus 2 by using part A. So give this problem a try and I will see you in just a minute. Alright, so let's start with part A. Part A is straightforward. 2x cubed minus 3x squared plus 1. I will write it in the following way: 2x cubed minus 2x squared minus x squared minus 1. So we have 2x squared, x minus 1, minus x minus 1, x plus 1. Alright, so we have a common factor, x minus 1, and we have 2x squared minus x minus 1. And let's factorize the second parenthesis. I will write 2x squared minus 2x plus x minus 1. So I have x minus 1, 2x x minus 1 plus x minus 1. So I have x minus 1 squared, 2x plus 1. And now notice that this is of course greater than or equal 0 for all x be greater than minus 1 half. Because here we have square, and well, if x is greater than or equal minus 1 half, then this is also greater than or equal 0, which proves part A. Because for part A we wanted to show this inequality for x is greater than or equal 0, well, it actually holds for bigger interval. Part B, more challenging. Part B, we will show first we will show that, well, 1 minus x, that maybe let's write that 3 1 minus x, 1 minus x plus x squared is greater than or equal to 2 1 plus x cubed minus 2. I will show this inequality. Notice that this is equivalent. I can multiply this by 1 plus x cubed. I can of course do that because I am assuming that x is greater than or equal 0. So for sure I am multiplying by a positive number. And notice also that what do I have? Well, 1 minus x stays the same, but 1 plus x cubed can be written in a different way. It's 1 plus x, 1 minus x plus x squared. Greater than or equal 4 times 1 plus x cubed, 1 plus x cubed, minus 2 times 1 plus x cubed. Right? And now, simplifications. This cancels with that, this with that, and we have 3, 1 minus x squared, greater than or equal 4 minus 2, 1 plus x cubed. And now 3 minus 3x squared greater than or equal 4 minus 2 minus 2x cubed. And let's put everything on the left hand side. 2x cubed minus 3x squared. Here we have plus 2, so we are subtracting 2, so we have plus 1. Greater than or equal 0. And notice that this is true, because this is exactly the result of part A. This holds for all x greater than or equal 0. Alright. And by the way, you may wonder, how on earth have I come with this idea that we should put 3 right here, 2 right here, and minus right here? Well, my line of reasoning was like that. Well, on the left-hand side of the inequality which we wish to demonstrate, we have expression of this kind. Expression of this kind is in our assumption, so I have connected this times that. Well, and this constant, I try to choose these constants in such a way that after this crucial multiplication, I get the inequality which was the subject of part A. And it was a matter of a bit of experimentation. Alright, so now, you know what, I will take this inequality. I will take this, copy it. Of course, it holds not only for x, but for y and z as well. So let's change what has to be changed. So we have not y by z. Alright, let's take these 3 inequalities and let's add them together. So we will have 3 times 1 minus x, 1 minus x plus x squared, plus 1 minus y plus y squared, plus 1 minus z, 1 minus z plus z squared is greater than or equal 2 times 2, 1 plus x cubed, plus 2, 1 plus y cubed, plus 2, 1 plus z cubed. And we have what? Minus 6 after adding everything together. And now, if we go back to our assumption, notice that this sum is 3. This sum is 3. So, on the left-hand side, all in all, the entire left-hand side is just 0. And after division by 3, we can take this, divide by 3, and we will have that this is greater than or equal 0, which is exactly what we wanted to demonstrate. And this closes our proof. So, very nice problem, I'd say. It would be quite challenging without part A, because without part A, well, what's the idea of this estimate? It would be harder to get it. But fortunately, it was preceded by part A. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.